We don't even have a license.
I do. Sure. Okay, so when I talk about dividing polynomials, it is not simply simplifying across a fraction bar like you may have learned in Algebra 1. It is entirely different. I'm actually looking for a division quotient answer with a remainder. So before we get into the polynomial division, we're going to practice basic log division, since you probably haven't done it in a hot minute. So for example, 2,445 divided by 3. We're going to do this long division style just so we can practice, because most of you probably don't remember how to do it.
I do.
So, quiet, please. When I'm talking about division, there are two parts to any division problem. There is the original value that I'm trying to make smaller, which is called our dividend. This is what goes underneath our long division house or hat, whatever you want to call it. And then we have what we're dividing out, which is called our divisor. This is what goes outside of the long division hat. So when I set up this problem, I'm going to have 2,445, 45, not 44, divided by my divisor of 3.
Just spoiled it. You spoiled the ending.
You forget. Last time I tried to do this,
I just go to square root.
back in elementary school, I couldn't do this on no calculator.
Exactly. Okay. So I ask myself, how many times does 3 go into 2?
Doesn't.
9. So then I have to look at that first number grouped with the next number. How many times does 3 go into 24? 8. So I put that above the last value
This is so weird.
in the number it goes into. And then I take that value times my divisor. What's 8 times 3?
24.
And I subtract it out. Oh my goodness.
We bring down the 4?
And then we bring down our next value.
Draw the arrow.
It can only go in one
Hold
time.
on. Jane,
This is bringing me back to my elementary life.
I'm glad. Okay. So then I repeat this. How many times does 3 go into the value of 4? Once. 1 times 3 is 3, and I subtract it out. 4 minus 3 is 1, and I drop the 5.
And then 15.
And then how many times does 3 go into 15? And then 5 times 3 is 15, so I subtract it, and I get no remainder.
Just keep doing this.
So this answer that I just found is called the quotient.
Do we have to know this?
Yes.
I remember that word.
Vocab is very important.
I can never remember.
Yeah.
It smells like.
So next quiz. No, I'm doing it fine.
Is this ringing a bell for most of you?
No.
Yeah.
Oh boy.
It's like I feel ahead of my game. I used long division in my first credit math test.
That's good. Okay, next practice.
Oh, are we practicing
We
another one?
are going to practice another one.
Yes. I think we got it.
You think we got it? Good, because we're about to move into polynomials after this one.
No.
Okay, how many times does 4 go into 2?
0.
How many times does 4 go into 20? 5 times 4 is 20. Drop down the 8. How many times does 4 go into 8? 2 times 4 is 8. Subtract it. And then I drop down the 9. How many times does 4 go into 9? 2 times 4 is 8. I subtract it out. And I get a remainder of what?
1.
So my entire answer is this quotient with this remainder. So I write it as 522 plus my remainder over my divisor.
I don't remember that.
So 522 and 1/4, you could also just write it as 522 and 1/4. No,
We did do this.
we do. We're not going to write it as R1 or R3, whatever it is. You have to write it as the fraction.
We never did this. Yes, we did.
That was an example of a remainder.
Class, I'm not dumb.
Okay.
I mean, I am. But
I've never done
if we didn't learn this, I wouldn't know.
So we have our quotient. We put with it whatever our remainder is over our divisor. So I had a remainder of 1 and my divisor was 4, so I wrote it as 1 over 4. This is very important for our polynomial division we're about to do.
Wasn't there a point where you would like add zeros or something?
Forget.
No.
Okay, so I think we've done enough long division practice that I'd actually like to do a polynomial division now. It's gonna be fun.
No.
Today we are just doing long division of polynomials. Tomorrow I will show you another way.
Short division?
They say it's super easy, so trust the juniors.
Last time I trusted the juniors.
I don't trust them either because all their GPAs are like, well, right now we have a 4 from them, so probably 5s.
I've never did it. She stole my Xbox. She only goes for the That's a lot. Yeah, well, there's obviously no way I can possibly do this, so. No,
It scares me. It's a fake laugh.
Oh, I know. I graded it.
Was any of them no solution?
No. Okay, so I have the polynomial 4x cubed minus 9x squared minus 10x minus 2, all divided by x minus 3. Just like before, this is my dividend.
What?
Oh, hey.
This is my divisor.
How do you tell which one's which? Because of the.
The one that comes first in
Oh, yeah,
division is
yeah.
usually the bigger one, and that's my dividend.
I thought the same thing. Yeah.
I set up my long division house exactly the same as I did with those,
Easy home.
you want a home? Long division home? Okay.
No, this is not home.
We set it up the exact same way with the dividend under the house. However, we have to be sure we are not skipping any terms in our dividend or our divisor. So we need to make sure our exponents decrease 1 at a time. So I have a 3, a 2, a 1, and a 0. So I have no missed terms in that dividend. I must check for my divisor as well. I have a 1 and a 0, so I'm good to go. I set up my problem, and it becomes 4x cubed minus 9x squared minus 10x minus 2, all divided by x minus 3.
Oh.
So we set it up the exact same way.
This does not look fun.
You'll see. It is actually a lot of fun.
No. It looks like it.
It's fun to you.
Trust her. Trust her. She's never been this ecstatic for math.
She's a
before.
mathematician.
Ooh, I like that.
Well,
That just sounded good.
not in my presence.
Okay.
I'm pretty sure you like my math.
I forgot to put one on.
There was one that was really, really funny, and I can't remember whose it was.
What was it?
Okay.
It was definitely mine.
We can discuss it later. Are we all okay with how I set this up? So the long division works the same. You really not, Xavier? What are you confused about? Okay, just checking. Oh, okay, that's fine. You can hate it. That's okay. What we ask ourselves is, how do I get from the first term in my divisor to the first term in my dividend?
Doesn't x go into x?
What do I need to multiply by x to get to 4x cubed?
4.
A 4,
A 4.
and then how many x's do I need?
3.
There's 3 here, and I already have 1.
That's 2.
So I need to multiply by 4x squared to get to 4x cubed. Once I identify that, just like with the long division we did before, we take this and multiply it into each term in my divisor and write it under the appropriate term under our dividend. So 4x squared times x is 4x cubed. 4x squared times a negative 3 is negative 12x squared. I put that in parentheses, and I'm going to subtract it from the two terms above. So just pause here. Pause and look at it.
I'm confused what you.
Pause and look at it.
You took x and times it by 4.
Hold on. When you did the problem,
4x.
so we looked at x. So we still have to look at negative 3. Like we
No,
haven't
I
done
only
negative
pay
yet.
attention to the first term in my divisor and then the first term of whatever I'm trying to reach.
And then we only use that second term in this solution with the 4x squared.
When we multiply that back in, yeah. Okay, so I looked at the first term in my divisor, which was x, and I asked myself, okay, how do I get to 4x cubed? If it helps you to write it out, you can absolutely write this out as having an x originally, and then having a 4x cubed that I'd like to reach. What do I have to add to that x to make it into a 4x cubed? Well, I have to put a 4 with it, and I need 2 more x's. So I had to multiply by 4 and 2 x's, which is x squared.
Then you take
So then I took 4x squared and I multiplied it into each term in my divisor. 4x squared times x is 4x cubed. 4x squared times a negative 3 is negative 12x squared. I put that in parentheses, and I'm now going to subtract it from the terms above.
So 0.
Hold on. 4 minus 4 zeros out every single time. Negative 9 minus a negative 12 turns into a positive. And it becomes negative 9 plus 12, which is 3. And then the x squared stays the same. And I drop down my next term.
And you just do the same thing.
Huh?
Well, yeah, because it's an x squared, so you have to do something to it
Yeah.
to have something canceled out. Why don't they? It's just
Negative 9 minus a negative 12 became a plus 12.
Because 4x squared times negative 3.
You know what helps a lot, Jen? If we actually stop talking through this.
That's the only place you could put it.
That helps a
Because it
lot.
has to have its buddy.
Okay, so we're just pausing here for a second. I'm trying to get everybody to process what has happened. Anybody super confused still about anything? Like, I know there's confusion. I get that. The more we do it, the easier it does get. Anybody not understand at all how I got something? Brandon, now's your time to ask.
I'll figure it out.
Figuring it out? 4 times a negative 3 becomes a negative 12, and then minus a negative becomes positive, Madison.
Wait,
Yeah.
When you're doing when you use the 12x squared, what
Yeah.
do you multiply the
Wait.
What? Say that again.
What do you multiply the negative 3 by to get the 12x?
The 4x
Oh, okay.
squared. Yeah.
Where did the positive come from again? I didn't even.
Negative
realize
9 minus a negative makes this a positive.
Uh-huh.
So it was
Where's minus?
originally, I can't erase now. It was originally minus 12, but minus a negative becomes positive
Why are we minus?
because I'm subtracting, just like we did
Oh
a
my
normal long
gosh.
division. You're okay.
Yeah.
So now, sorry,
Why
Kate,
don't x
why didn't the x squares cancel? Because I had a 9 here and a 12 here. There was no way that was going to happen. They'll cancel out when I do my next step, which is the goal. We're not done yet. We're just pausing. Okay, so then I repeat the process.
You just
I'm going to ask myself, how do I get from this x to this 3x squared?
all 3 and another x.
A 3 and another x, so I call that 3x.
Oh, so do you want us to put plus?
If it's positive, yes, because it'll help us with our quotient later. So then I take 3x and I multiply it into each term in my divisor and write it under its appropriate term down here. So 3x and x becomes 3x squared. 3x and a negative 3 becomes negative 9x. Put it in parentheses and subtract. 3x squared and 3x squared will cancel out. I have negative 10 minus a negative 9 makes this a positive 9. Negative 10 plus 9 is a negative 1x. And then I drop down my next term. So now I have negative x minus 2
Because you
to get from x to 3x squared. Negative 9 minus a negative 12 became positive 3. And then I drop down the next term. And then I asked myself, how do I get from here to here? And that's how I got the 3x. Oh my gosh. No, go away. Let's change it. 3 times a negative 3 is negative 9, and then double negative became positive. And then I repeat it one more time. How do I get from x to a negative x? Negative 1. So then negative 1 times x is a negative x. Negative 1 times a negative 3 is a positive 3. Put it in parentheses and subtract. This zeroes out. I get negative 2 minus 3 is negative 5.
Oh, yeah.
And this is my remainder.
Wait,
Right here?
5. What letter is that?
Because when I did negative 1 times x, I got negative x, and I always have to subtract it. I asked myself, how do I get from x to negative x here? Which was my answer from the subtraction problem above.
So would the answer technically?
Hold on, we're going to write it in a second. I'm trying not to overwhelm you guys.
We don't have any homework tonight.
Negative 5 over.
So then our entire answer is this quotient with this remainder over that divisor. So I write it as equals 4x squared plus 3x minus 1 plus my remainder of negative 5 over my divisor x minus 3. And that's my entire answer.
Wait. What?
What's up, Bull?
What remainder of x minus 3 because you can't do anything more?
No, remainder of negative 5 because I couldn't do anything more with it. There's no way for me to get to go from an x to a negative 5.
Why did you put x minus 3 after?
Because it's remainder over divisor. And my divisor is x minus 3. You're not going to drop out.
What?
You're not dropping out.
No, I said I don't understand what they're dropping down.
Okay, it's just like when we did like the long division with the numbers. Whatever was left, we dropped down the next term. So we'd have 2 numbers to take out. Okay, so you get to do the next problem. That's what I'm hearing here.
I don't know how to get home with it. Making sense.
Okay, so we're going to do another one
Yes.
as a nice, lovely little practice. How many of you absolutely hate this with every
I
fiber of your
love
being?
it.
How many of you don't mind it so much? Okay, just wondering.
But is there
Which
not?
is for your brain.
Always in there. And some people can get that and some people can't. That's okay.
This lesson doesn't bother me. It's just like a 15.
Other things before, oh yeah, I know. I can't either. It's fun.
I think the most.
Not that it's very hard.
I can't read that. I agree that we need to keep our talking to a minimum because there are actually people trying to figure this out. If you have an idea for what's happening next, fantastic. Keep it in your brain and see if it actually is what happens next. Okay? Once I've identified my dividend and my divisor, where the top here is a dividend and the bottom here is a divisor, I can go ahead and set up my long division house. What do I need to be careful of as I'm setting this up? What do I need to check for? Maybe that's a different question. Any skipped terms. So I look at my exponents to decide this. In my dividend, I have a 4, a 3, a 1, and a 0. Did I miss any numbers in there? A 2. I do not have an x squared term there. So I'm going to need to fill in with a 0 x squared. Sam?
What do you mean by skip?
So I have an exponent 4, I have an exponent 3, I have an exponent 1, and an exponent 0. I skipped from 3 to 1, which means I don't have an exponent 2 represented here. That's what I mean by skipped term. So I have to fill that in with a 0 in my long division house. So when I do this, I have negative x to the 4th plus 5x cubed plus 0 x squared minus 10x minus 4, all under the long division house. I also have to make sure my divisor is not skipping any terms. I go from an exponent 1 to an exponent 0, so I'm good there. And I'm dividing out x plus 1. When I start this, I ask myself, how do I get from the first term in my divisor to the first term in my dividend? I think about numbers first. How do I get from a 1 to a negative 1? I multiply by negative 1, right? How do I get from an x to an x to the 4th? How many x's do I need? 3. So I need to multiply by an x cubed. So altogether, I'm multiplying by a negative x cubed to get from x to negative x to the 4th. I then take this and multiply it into each term in my divisor. Negative x cubed times x is negative x to the 4th. Negative x cubed times 1 is negative x cubed. I put it in parentheses, and I subtract it from the terms above.
Okay.
Hold on. Raise your hand if you have a question. Sam?
How did you get x minus 3? The second number in the parentheses. How did you get that?
Negative x cubed times 1 gives me negative x cubed. Then I do the subtraction. So a negative minus a negative becomes a negative plus, which means it's going to cancel out. Then I have 5 minus a negative, which makes it 5 plus, and that's a 1, so this becomes 6x cubed. And I drop down my next term.
6x cubed is the second answer.
Yes. Did you drop down the next term after that?
Yeah, I got 6x cubed minus 10.
Do we just
Oh.
repeat the problem?
No, it should be plus 0x squared. You didn't fill in your
okay.
0. And then also I'll pause until you get that written. I have a 0x squared between the 5x cubed and the 10x.
Wait, how would there be a plus sign in the middle of the x cubed? One's negative.
But this was originally a negative, but it was a double negative. So 5 minus a negative became 5 plus. Okay, are you good now, Brandon? Did you get it written?
Yeah, I got it written.
Okay, so then we ask ourselves, how do I get from the first term in my divisor to the first term in my new dividend portion?
My 6 1 2.
Hold on, think in your head. How do I get from an x to a 6x cubed? What number do I need to multiply it by? 6. How many x's do I need to get from an x to an x cubed? So I need to multiply by an x squared. So altogether, I'm multiplying by 6x squared. So then I take that 6x squared and I multiply it into both terms in my divisor. 6x squared times x is 6x cubed. 6x squared times 1 is 6x squared. I put it in parentheses and I subtract it from the 2 terms above. The first terms will always cancel. That's why we do this. And then I have 0 minus 6, which is negative 6, and it's going to be an x squared. And then we drop down our next term. So now I have negative 6x squared minus 10x that I'm considering. I'll give everyone a chance to catch up. Is this making a little more sense to any of you who were confused before? Okay. It is really one of those things, the more you practice, the easier it is. You good, Brayden?
Yeah, I can't remember.
The x now?
Yeah.
By whatever it takes to get here, which is our new dividend portion.
Oh.
So what am I going to multiply x by here to get to negative 6x squared? I need the number negative 6, and then how many x's do I need? Just one, because I already have an x, and that's an x squared. So I'm going to multiply by negative 6x. And then I multiply it into both terms in my divisor. So negative 6x times x is a negative 6x squared. Negative 6x times 1 is negative 6x. Parenthesize and subtract. Let's remember that when I have parentheses and a subtraction out in front, that actually distributes to both terms inside of it. It doesn't just apply to the first term. That's a very common mistake I see. So these, sorry, what? Yeah, so a subtraction is the same as a negative out in front of parentheses, so it applies to each term inside the parentheses, not just the first term. That's a very huge mistake I see. So those cancel because that became a negative 6 and then a plus 6. Then I have negative 10 minus a negative 6 becomes negative 10 plus 6, which is what? Negative 4, and then it's an x. And then I drop down my last term, which indicates this is the last part of this long division I'm going to have to do. And then I ask myself, how do I get from x to a negative 4x? Shane, you can't answer. How do I get from x to a negative 4x? Just multiply by negative 4. I multiply that into both terms in my divisor. And when I do, I get negative 4x minus 4. I subtract that out. The first term cancels. What about the second? Also going to cancel because it's going to be a negative plus, and it's going to be the same values. So that means I have a remainder of 0, which means the quotient on the top is my entire answer. There's also something else unique about this. When we're doing polynomial division, usually our goal is to find a factor, which is something that divides evenly from the dividend I originally started with. If it divides evenly, it means there was no remainder left after I did whatever division process I did. So having a remainder of 0 actually indicates that what I divided out and what I have left are both factors of my original dividend. This is called factor theorem. Yeah, it's kind of cool, right?
I don't even know what that means. I'm gonna go.
So because I had no remainder left, it indicated that x plus 1 is a factor or a 0 of the polynomial I started with. I'm not going to expect you to memorize that or remember it even for next time, but I wanted to introduce it. Okay? So we are going to stop here because I think I've kind of melted some of your brains.
It really is fun. It can be kind of confusing.
Right.
But
And I am going to show you another form of division tomorrow
yeah.
that you guys might like a little bit better. It does have its limitations, but it's usually more, it's better received than this typically is by students.
This is just.
You also only have 15 minutes left, so find something productive to do. These notes are on Canvas though. What? No, I wasn't able to upload it because I don't have my computer.
Works for me. I could basketball.
I would also like to say something, just because it was said earlier and I think it needs reiterated sometimes.